Hello, everyone, and good day. My name is James Mancini. I'm one of the original founders of Netreo. And today we're going to be talking about how to automate network management with the specific goal of reducing the admin burden to as close to zero as possible. During the presentation, if you have any questions, please enter them into the question section of the GoToWebinar interface, and we'll make sure to get those answered for you. Now let's get started. So network management automation can take a lot of forms. Which ones work for your particular scenario is going to depend on what your network architecture looks like. So obviously this is going to be different between different size organizations or public entities with correspondingly different requirements and needs. Now, we work with a lot of different size organizations, and all of these different architectures are things we have to potentially work with. Things like on-premise cloud, hybrid cloud, software-defined networks. We kind of run into a little bit of everything. So let's sort of look at where the current trends are and what that means to us in terms of automating our management. So software-defined networks are probably the fastest growing segment, and they're quickly becoming a major force in data networking overall. When properly considered and installed, software-defined networks can really transform the enterprise environment from a legacy structure of static connections to a next-generation infrastructure that can be managed in real time. And this enables next-generation applications and collaboration for both lower cost and better service levels. But the migration to SD-WAN is sort of already started. Last year, we saw about 30% of WAN refresh initiatives, including SD-WAN, but that number is expected to more than double to over 65% over the next 2 years. However, SD-LAN adoption has really lagged, and that's largely because of a less well-defined ROI and much more niche use cases. So let's take a moment to look at how this trend affects how we manage our networks. So in a traditional network management model, on-premise equipment, traditional devices, all of the performance data is collected from the devices directly. So this is the model we're all familiar with. The management system reaches out to the devices and interrogates them using an API or SNMP or another protocol like WMI. And then those devices in turn return all of that data back to the management system, which processes and stores the data for alerting, reporting, and analysis. So this is sort of the basic way that network management has worked forever. In a software-defined network, though, there's another layer of abstraction that gets added. It's called the orchestrator. And this is usually a cloud-hosted system, but it can also be a physical or virtual server. And all it's doing is it's running software that creates and manages the network. So it tells those endpoint devices, the CPE, exactly how to build the network and what to connect to and what protocols and addressing are needed to create those connections. Now, depending on the vendor, most of these, as I said, are cloud hosted, but you can also have on-premise systems, which is probably more common in SD-LAN than SD-WAN. But the majority of what we're seeing is really cloud hosted systems. The orchestrator is controlling and adapting all of the network parameters directly, either by leveraging virtual CPE devices or by leveraging embedded systems like routers and switches. So this removes the manual configuration that would otherwise be required. However, what this means is that those CPE data, those endpoints, typically expose minimal management data directly. So now we have to interrogate most of the critical performance data directly from the orchestrator using an API. And this is a really critical point, as a lot of software-defined networking vendors today are relying on their own cloud management portals nearly exclusively. So they've really lagged behind in API development. Now, while that might work for small organizations, larger and more agile organizations need centralized command centers, and creating additional information silos is not the best way to do that. So orchestrators can also push that data directly to the management system using trap-like mechanisms, but these can also be very inconsistent between vendors. So different vendors are going to have different capabilities here or different APIs that they have to use. So it's important to make sure that you've got a management system that's got good APIs in place. Now, this really means that in a software-defined network, the device-centric collection model migrates most of the telemetry collection to instead collecting API data from the orchestrator itself. And for this reason, it's critical to find out what APIs the vendor supports and what data they make available. Relying on a vendor's built-in management portal seems like an easy answer, but it creates an isolated information silo, which creates multiple points of administration to create and manage things like alerts or schedules, performance monitoring, and reporting. And this is also going to increase the training burden on the staff. Centralized monitoring is critical as it allows you to quickly determine whether a problem is global in nature, and knowing which alerts are outstanding when a major problem occurs helps to identify the proper support teams to engage and reduces the time required to find the root and resolve the problem. Because of the really slow adoption rate we're seeing with SD-LAN, though, we expect most enterprises are going to remain a hybrid of hardware-based LAN networks and software-defined WAN networks for several more years at least. So it's important to adopt a management strategy that's going to allow you to embrace these changes as they happen while still supporting legacy infrastructure. So how do we make sure we can handle these changes without stretching our already overburdened staff even further? The answer is automation. We need a way to keep up with rapidly and dynamically changing environments like SD-WAN while maintaining visibility, avoiding blind spots, and keeping up our service levels. So we define automation maturity in 4 stages. And those stages are discovery, monitoring, response, and artificial intelligence. Now, OmniCenter uses 3 of these every day and has been for a while, and we're currently working on artificial intelligence for later this year. So let's take a look at how we define these, and you'll start to see where your organization might be today and where you want to get to. So the first stage of automation is what we call discovery automation. This technology has been around in its most basic form forever. And today, auto discovery has changed quite a lot. So it's no longer just scanning the network for new devices, although that's still important in a lot of environments. Today, there's a lot of things you can't scan that way, though, like isolated virtual systems, DMZs, cloud hosted systems, microservices, containers, just to name a few. So modern management systems will leverage the power of API integration to make automated discovery faster, more reliable, and much more complete without creating network traffic problems. So we leverage these APIs to learn directly from systems like vCenter, Azure, AWS, Google Cloud, as well as things like SD-WAN orchestrators, um, in order to automatically build in all of those systems as they're added into those platforms. But we also build in powerful and discrete scanning capabilities. So if those are still needed, we still have those capabilities. Now, stage 2 is what we call monitoring automation. And this is where new devices added to monitoring and getting them correctly configured is no longer requiring manual intervention. So to reach this stage effectively, the management platform must be able to identify new systems not just at the OS level, but also to detect things like which services or applications are running on them so that we can make the right decisions about what exactly you want configured on that system. For example, bringing up a SQL server as a virtual machine should enable monitoring of the OS, the SQL application itself, event log monitors, who to alert when it has a problem, all of the virtualization statistics that are unique to that platform. And it might be different depending on um, a SQL problem versus an OS problem may need to notify different people, and what kinds of thresholds, anomaly detection, what kind of statistics we want to watch on it. All of that needs to be built in an automated fashion so that it doesn't require an operator to go down a checklist to make sure all of the right things are being monitored on that system every time we bring a new system up. It should also include putting it in the right categories, sites, business workflows, the groupings that drive your reporting so that newly deployed systems always show up in the correct reports. We've seen a number of instances where customers have, not done the automation steps and have failed to add new systems to existing reports, and then they find blind spots and things start going wrong that they weren't aware of because they weren't watching the right things. So if we can automate all of that categorization and reporting, that gets us even further down the road of removing the admin burden of adding these systems in. The third stage is what we call response automation. And this enables the management platform to take independent action to remediate a problem before the NOC or the engineers have to do anything. Now, this can be a big step because we're giving up some control, and a lot of organizations are going to insist on keeping that manual operator intervention in place to at least approve the action before it's taken. This is what we kind of call the click to reboot button. OmniCenter supports doing this either way. But in order to effectively automate response, we have to allow different actions based on things like time of day or day of week, in case you want a different response during business hours. One of our customers, for example, set it up so that after hours, the system will automatically reboot their web server if it fails. But during business hours, it'll notify the NOC and let them take manual intervention, but they're not staffed 24/7. So they've tried to speed up after hours resolution by automating some of it. It should also allow for dependencies, like taking different actions if there are other servers running the same application that are having a problem at the same time, for example, because that may indicate that we've got a different root cause and just restarting the service isn't going to do it for us anymore. And of course, we need to be able to do this across different platforms, whether they're routers, Windows, Linux switches, or cloud hosting providers. And this requires different methods of interaction with those devices, as some are going to require things like API calls, and others might need SSH commands or PowerShell commands, or even, Telnet for very old systems. Finally, we're talking about artificial intelligence. So if you thought that the last step was giving up a lot of control, this is well beyond that. So there's obviously a lot of different definitions around what exactly constitutes AI. Here we're using the term to define systems that can make autonomous decisions. So for example, if the system can learn the regular paths the applications are taking across the environment, an AI-based system might alert you of potential problems for that application based on path issues or congestion, or it might just reroute that traffic for you automatically. Or it might notice a correlation, for example, between specific log messages and a later application failure and restart some services proactively to remediate the issue since that was the solution the last time the application failure occurred. Ideally, a working AI management system should make these connections and potentially take actions based on learning your environment, as well as established industry best practices and scenarios encountered across other customers. The only real downside of this is that AI drives very high resource requirements. And typically this means you're going to have some of the computing power cloud hosted in order to help out the management platform sort through all the data that's coming into the system, as well as do things like integrate data from other customers and create a common knowledge base for specific types of failures. But this generally means we're going to have a connectivity dependency for full functionality in an AI-based system. Now, let me kind of walk you through OmniCenter's automation architecture. There's a lot of different parts to it, and it looks complicated at first, but it's actually pretty simple. So let me step you through it. We start with discovery, which is driven by connecting with APIs, cloud providers, and SD-WAN providers to learn new devices. It includes scanning, where we can automatically learn about connected network segments and find new devices to monitor that way. And there's also APIs that allow inbound communication, so process integration and other kinds of automation tools like Puppet or Ansible or Chef can push data in as we provision new systems and have them automatically discovered by the management platform. So together, this is kind of how we define the discovery automation process. Now, new devices that are added through this kind of discovery are passed off to what we call the auto configuration process. And auto config uses rules that you can edit, create, or download from the cloud to automatically put the devices into the correct categories, applications, sites, business workflows, and then use all of those to drive configuration data. So the idea is that we can take those auto configuration rules, they'll automatically sort devices based on name or location or processes that are running on them, put them in the right kinds of organizations. That drives our reporting, as we said, and the reporting can then be automated, but then it also will push what templates get applied to that device. And those templates can define all of the different settings for the device, including authentication, alerting, thresholds, configuration alerts, all those kind of rules. And that configuration then drives the monitoring engine. The monitoring engine drives the dashboards and custom views, but it also controls sending alerts via email, application push, webhooks, ticketing integrations, things like that. But it also then drives active response. So now we can automate response actions and execute commands via CLI PowerShell or push commands to APIs to do things like restart virtual machines, deploy new containers, or reset cloud resources when needed. Now that auto discovery engine includes both the subnet-based scanning as well as API integration like we talked to, so we can quickly identify new systems as they're provisioned. We've got hooks into a lot of different kinds of APIs. So for example, finding new Meraki edge routers or as you bring them online, or start monitoring new AWS instances or new virtual machines as they're spun up. We can also use that subnet scanning engine to identify subnets in the environment and find new systems there. So it's designed to use the minimum amount of bandwidth possible and put minimal load on the scanned systems, but to dynamically learn when new things are added to the network, new subnets are brought online, and to allow you to control whether or not those subnets get scanned for new manageable systems. So you can go in and tune your scanning to exclude subnets that might have sensitive equipment on them that doesn't react well to scanning, for example, or you can turn scanning off entirely if your network is entirely automated through the APIs. Now the open APIs that we provide are designed to make it really simple to integrate provisioning of new systems. So you can do things like link OmniCenter into your CMDB or inventory system. So as new resources are brought online, they can be pushed into monitoring and have all those auto configuration rules applied to them to fully provision them as they're brought online. And you can link the provisioning system directly into monitoring by pushing data into OmniCenter from any other automation platform. And so this is designed to remove that manual add to monitoring step from the process, saving you time and eliminating the possibility of human error. So the idea is either way, we're getting new systems, whether we're learning them via the API or they're being pushed in via the API, or we're finding them in a scan, we can apply all of the settings to them and really get that monitoring automation knocked out. Everything that we want set for those systems can be pre-configured, and based on rules that we define, can get programmed into the system with all of the necessary alerts and settings and service checks and all the different kinds of things that we want to be monitoring on them. Now, those auto configuration rules, it comes with a set of rules that are predefined to help you get started, and you can easily customize or create new rules to fit your environment. You can use these rules to set device attributes like categories, sites, and business workflows based on any different device criteria. So things like what processes are running, what ports are opening, what the device is named, or even SNMP values. This makes sure that there's no manual provisioning step so that we can make sure the devices end up in the correct reports and they always get the right settings applied. And as I said, these are automatically applied to devices as they're discovered, regardless of what method is used to add them or what platform they're running on. You can also enforce these rules. So I can reapply these rules every time a device is rediscovered, or on a periodic basis, to make sure that everything stays configured the way I want it, and I can enforce that via these rules. Now, we use a template-based system to create this automation. So those auto-config rules then drive those templates, and we can dynamically apply all of the different templates that apply to the devices. So the idea is that all the different settings that we want applied are applied without manual intervention. For example, a new SQL server coming online would not only get the basic Windows Server settings, but it would also get the SQL specific application checks and settings, and the SQL team will get alerted whenever there's a problem with it. You can use these templates to define authentication credentials, escalation, and as well as active response automation. So it's designed to be flexible enough to really meet the needs of a large global enterprise customer, but be simple enough to implement for even a small IT department without a lot of training or dedicated personnel. So I'd like to take a minute here to show you what we're talking about before we move on to kind of demonstrate the concepts, as well as the specific ways that OmniCenter achieves them. So bear with me for 1 second here as I switch over. Okay. So this is the OmniCenter default dashboard that you land on. If you haven't created a custom dashboard, many of you are probably familiar with this screen or have seen it before. So on this screen, I'm actually going to go in and I'm going to define one of these templates that we talked about. So I'm going to go in and edit one of my templates here. And by going to template administration, I'm going to look at my MS SQL template here and edit its contents. So I can see here in my MS SQL template, I've got some authentication credentials defined. I've also got some different components that are built in here, like I'm automatically creating service checks for all my SQL processes. I've got some thresholds predefined for SQL specific things that I might be wanting to watch on those systems. And all of these can be defined as either high, low, anomaly, or all of the above. So I can set looking for unusual behavior using anomaly thresholds, or I can set look at specific values for, when I cross a specific value for a given amount of time, I want to get notified on it. And so I can define these in the template so that when they're applied to a device, all of these different settings get pushed together all at once. So if I want to go in here, for example, and change one of the settings on what I'm looking for as far as database blocking thresholds here, I want to get notified if it's higher than 1 for a 5-minute interval. I can also define things like look for anomalies. So if it gets unusually high, I can create an anomaly threshold that'll notify me immediately when a blocking process happens that's not normal for this time of day or this day of the week. So I can kind of define all those different thresholds within the template, and then that template can get linked into one of my organizational units. So for example, if I want to go in and link that to a business workflow that I've created, this is our strategic groups functionality. I can actually go in here and say, I want to create a group specifically for my database servers. And when anything gets put into the database servers group, I want to make sure that it actually gets the particular template applied to it. So I can go in here for my database group, edit that database group and apply the template that way. Or if I want to go in, for example, and do this via another type of grouping, like if I want to go in via category, I can create a category specifically for database servers, affect what template gets assigned to it. So I can set my MS SQL template specifically for my database servers group. And now when any new devices are put in that database servers group, they'll inherit all of the settings from that SQL template, as well as any other templates they would have inherited from things like what type of device they are or where they're located, or any of the other kind of criteria that I've set for those devices. Now all I need to do is go make a rule that says that when a new device is discovered that's running a SQL process, go ahead and put it in that group. So I can create that with one of these auto configuration rules. So by creating an auto configuration rule and saying that I want to set this to be category database servers, for any time I have a auto started Windows service that matches SQL, now as part of that auto discovery process, I can go in here and find running processes on the system. If it's running SQL, it'll automatically be moved into the database servers category for me, which will cause that template to be applied, and all of those different thresholds and alert settings and any automation that I've created for it will all roll down onto that system all at once. So it's, again, designed to automate the process of adding new devices in and discovering new devices and just making that whole automation process completely automatic. So now I'm going to take a second and talk more about active response. So one of the things we talked about, the next level of automating beyond that management automation, where we now have all of the configuration steps completely automated. We don't have to think about them. Whenever we bring on a new server, we know all the settings get set the way we want them. The next level, though, is to automate the response to the alerts. So this allows us to take whatever actions are appropriate in the event of a failure or even an unusual condition like a network anomaly by automatically executing commands on devices or by sending API calls to your applications or cloud providers. So you can do things like link in CLI commands via SSH or PowerShell, or use APIs like webhooks so the monitoring system can restart ports, deploy additional containers, retest applications, even dump diagnostics in response to an issue as it happens. So we can actually have those, part of the monitoring system and part of the alert that goes out. We can get all those diagnostics as part of the issue. Now, some people are uncomfortable with automatically executing commands like restarts. So what we've done is we've allowed you to control those commands manually through operator intervention if you prefer that method. So if you want to add a click to restart server function directly into the web interface of the monitoring system, but then limit that access only to administrators, there's a very easy way to do that. So you can actually do things like I mentioned before, set it up to automatically restart after hours, but require manual intervention during business hours if you want to, and that's all controllable by time of day and day of week. Now, keep in mind, if you're going to automate responses, maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade is going to be kind of exciting because the monitoring system is going to start taking action in the background. So if I go in and pause an application, for example, to be able to install a new version or do a deployment, and suddenly the server reboots because I didn't put that into a maintenance window in the system. And we allow you to create maintenance windows via the web application. You can do it via the iPhone or Android application. You can also do it via an API. So if you want to integrate it with existing change management systems or change control systems, so it will predefine those management windows for you, you can easily do that as well. Now, incident management is how OmniCenter allows us to create advanced dependencies. So the goal is to reach 0 false alarms here. And they also allow you to easily override configured actions in order to send a customized alert or suppress a redundant alarm or to automate a specific response. So you can configure these dependencies based on grouping. For example, if you're seeing a bandwidth issue at a particular site, you could suppress any latency alerts for the same location because you know they're related to that. Or if you're running a cluster of systems, you might want to take a different action based on if the other cluster members are down at the same time. Now, detecting unusual behavior instead of just relying on static alarm settings is another key way to get proactive with the monitoring and to really get out of that firefighting mode so we can start on preventing the fires in the first place. And the idea here is to detect things before they actually become a problem, but when they are behaving unusually, so we can bring those to your attention. So the idea is that OmniCenter detects unusual behavior with this anomaly detection algorithm. So you can apply this to almost anything, like a process on a CPU, CPU utilization for a specific process, memory usage, number of running processes, even looking for unusual log messages, or an unusual number of a type of log message. So the idea is that the application suddenly goes from 10 login failures per hour to 1,000, and then maybe that last deployment didn't go as smoothly as we expected, or something else has gone wrong, and we have a starting place we can go troubleshoot at. So we automatically generate a baseline behavior model using the large volume of historical data that we retain, and we automatically adapt that baseline as the environment dynamically changes and evolves. So anomalies can be detected based on changes in baseline behavior looking at time of day, day of week, or even hour by hour. So the idea here is all just to find unexpected impacts. So like a software change causing unusual CPU behavior on a backend server. So to give you an example, one customer of ours discovered an issue where normally at 10 a.m. on a Wednesday, their database server is chugging along at 50 to 60% utilization, but this particular day it was running at 15%. Now, it turns out that a change that got pushed into the UI the previous night made it confusing and customers weren't able to complete their transactions properly. Now, that sort of anomaly is the kind of unusual behavior that never would trigger a static threshold that was looking for 95% plus CPU utilization, for example. But in this case, it was able to reveal a problem long before it actually had a major impact on the operations, or caused a really big drop in orders that would have resulted from that. So a key point of automation is to make sure you're not spending all your time putting out fires at the expense of dealing with real business requirements and moving the organization forward. And the most effective way to do that is to reduce the alerts you're sending out of the system. The way we always recommend to do that is by reserving alerts only for things that are truly immediately actionable. So if you're not going to react to a notification as soon as it comes in, you shouldn't be alerting on it. So for example, if you're getting alerts when a hard drive reaches 90%, but then you're sort of filtering those out because it's not urgent, and you figure you'll circle back and check on it and see if it's still growing in a couple of days, two things are going to happen. First, sooner or later, you're going to get an application failure because you forgot to circle back on that alert before the drive filled up. And second, you're conditioning yourself and your teams to ignore alerts, and it's guaranteed that someone someday is going to ignore the wrong alert, and you're going to have a major problem on your hands. So a better way to do that is to use reports. So you can be kept up to date on things that may not need to get folks out of bed, but you can still stay informed. So, getting an email in the morning showing you which printers have low toner is a lot nicer than being alerted every time it happens. And then you can schedule replacements for non-intrusive time so you can actually prevent an interruption of service. A key success factor of making this work, though, is to make sure that the reports are scheduled and automated, so that nothing gets missed, and you really don't want to depend on some poor soul to take time every week to run and send a report. That's a task that's sure to get skipped when the team is up to their necks in alligators, or when the designated engineer is on vacation and the person covering for him has no idea how to work the reporting software, or isn't even aware that that's one of the things he's supposed to be doing. So I'm going to take another minute here just to demonstrate some of the concepts we just talked about, specifically active response and automatic remediation, as well as report scheduling. And I think you'll see how simple it is to really get to the next stage of automation using OmniCenter. Okay, so we're back to the dashboard here. Now, the first thing I'm going to do is I'm going to create an active response action. So I'm going to go into my actions menu, and I'm going to create a new action group. And there's also a cloud library of these actions that you can download, so you can add supplemental ones to your system without creating them yourself if you want, but you've got the flexibility to kind of make them do exactly what you need to in your environment. So for this one, I'm just going to do a very basic one. I'm going to do a reboot Windows server. And then I can set whether or not this alert action or this action group can be executed manually. So if I want to limit this, for example, so only administrators can manually execute this action, I can do that. And then I have the option to tie this in to automatically happen as well, or just allow administrators to do it manually. So if I want to give them that particular flexibility, I can easily do that. So now when I've got that reboot Windows action created, I'm just going to call this action reboot. And what I'm going to do is add a specific active response to that. So I'm going to add a PowerShell command here to just do a really easy server restart command. And then I can configure what hours it's eligible to run this particular command. So if I want to limit this to non-working hours only, I can easily do that as well. And when I add that method in, now I've got that action group to restart the server. Here's my reboot Windows that I just created there, and you can see my active response Windows. There's the command that it's going to run, via PowerShell. So now that I have that defined, I can tie that into a template. So if I go back, for example, to the template that we worked on earlier with the MS SQL, I can add that as an active response I want to take when a particular type of problem occurs. So by editing the template, I can add that action in as something to do if the host goes unreachable, for example, or if a particular service check fails. I can actually go in and say, I want to make sure that as a result of that particular action, I want to take my reboot Windows action and save that directly into the template. So now whenever those devices are linked to the template, they'll automatically be updated to receive those new settings. So all the devices in my database server category will get that, and it'll execute that command on the device automatically if the SQL service fails, but only if it's after hours, because that's what I defined in the action itself. So it gives you a lot of flexibility in terms of how you want to orchestrate that response, or if you want to require some manual intervention for it as well. So the other thing we talked about was reporting automation. So getting away from alerting all the time and getting reports instead. We try to make it as easy as possible to do that. So all of the reports in the tool are designed to be kind of runnable in real time. And then you can also take any of the reports that you're looking at in the tool and turn it into a scheduled report. So for example, here, if I want to go in for, and run a process that says all of my infrastructure devices, I want to get a latency report for these guys. I can go ahead and pick that round trip time latency, and it's going to give me a sample report here, but I can go in here and open the filter option to change my output. So now I want to look at, let's say I want to do last 24 hours. I want to look at the highest, and I'm going to store those in the form of a stacked graph so I can quickly spot any outliers. And it's going to give me a pretty little graph here that I can dynamically click and zoom on to see exactly what's going on at any given time and what the values are. Once I've got this graph returning the data that I want, all I have to do is click the email and schedule button, and I can either send this right now, or I can add it into an existing custom report, or even create a new custom report based on this particular report. So I'm going to go in here and call this one my new latency report. And I can go in and see where that report is. Now I can add additional sections to that report if I want to, or I can simply schedule it to go out. So now I know this particular report, I created it to go out daily because it's got the last 24 hours. So I can put my email address here, go in here and say, I want to go ahead and send this daily at midnight. So I get it in the morning, and I'm going to look at the default time frame, or I can set this to last 24 hours. Decide whether I want this as PDF or a CSV if I'm integrating this with another project, and I can set the schedule for this report. You can also have those schedules set to go out to things like distribution lists or to shared folders. So if I want to push that PDF into a distribution list where I've got a nice archive that I can go back and look at all of the historical reports that came out, I can very easily do that. And the idea is that any of the different reports I'm looking at in the tool can just be added in to one of those custom reports. I can create a new one. It doesn't require a lot of specific knowledge about our product. It doesn't require any SQL knowledge or any crystal reports or any kind of scripting language. I can literally just take almost any of the different web pages I'm looking at in the tool and click that automate button to make that part of my regularly scheduled report. So now I'm just going to take a moment to talk about who we are for those of you who haven't worked with us before. So Netreo is now in the middle of our 20th year, and we've been profitable since year one, providing easy to use and comprehensive network management systems for private and public enterprises around the world. We run Monitoring Product of the Year from Network Computing UK 4 years running now, and we made the Inc. list of fastest growing companies for the last 2 years as well. Last year, after 18 successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts to allow us to grow even faster. And our track record in enterprise business speaks for itself, with customers like Wells Fargo, Aon, Partners Healthcare, SpaceX, and many others with whom we've maintained more than 95% customer retention since day one. So now I'm going to take a few minutes to address any questions that you may have. If you haven't already put them into the GoToWebinar interface, please do so. And I'm also going to launch a poll. So if you'd like us to follow up with you to give specific information or to discuss your specific requirements or your unique environment, you can let us know that way, and we'll be sure to reach out and get in touch with you privately as well. Okay, so first question, what kind of APIs are supported for alert actions? So that's a great question. There's a number of different types of APIs that we can integrate with directly. Things like, plugging into ServiceNow for ticket integration, or as I mentioned, SSH or PowerShell to launch commands directly against devices. But we also support JSON-style webhook APIs, which gives us compatibility with literally hundreds of other kinds of network management, automation, and notification systems. So everything from, notification management systems like OpsGenie to being able to plug directly into cloud hosting providers to, reboot remote servers via things like AWS or, digital cloud hosted systems. We can send specific API commands to those using a webhook type interface to be able to reset those. You can also use webhooks for notifications. So as I mentioned, if you're trying to get integration with things like ticketing systems or ServiceNow or notification managers like PagerDuty and OpsGenie and things like that, that's very easy to do as well. So next question, can I assign a specific dashboard to a specific user? Yes, actually the tool is designed so that I can create custom dashboards and then tie them into specific application workflows. So when someone clicks on my database screen, they get a specific database dashboard, or when my database administrators log in the tool, I can have that be their default view as well. I can also restrict them to only seeing specific devices if I want to be able to do that. So it's designed to be very flexible in terms of how those dashboards are displayed and exactly what's on them. You can also assign dashboards to what we call unauthenticated pages, so you can actually give kiosk access to a specific page that doesn't allow any drill down or confidential information, but it can be accessed from a monitor located in the executive suite, or you can put it up in the operations center if you want to, without having to worry about authentication for those specific pages if you enable that. Next question, how far does OmniCenter scale? So OmniCenter is designed to run either as a physical or a virtual server or in the cloud. So it really depends on how many resources it's given. If it's running on a physical server, we have different sizes of physical appliances that'll allow you to scale anywhere up to 25,000 or so devices in a single appliance. You can also use multiple appliances to scale horizontally to either do things like distributing, the data collection to multiple different locations to spread out the load, or to allow you to access restricted network segments via a dedicated probe, for example. Or you can cluster multiple OmniCenters together using what we call the overview functionality, and that allows you to take an almost unlimited number of OmniCenters and combine them into a single screen for purposes of consolidating all your reporting and administration into one web interface and really making that seamless for you. In a virtual environment, it depends on the resources that you give the system, but we've got customers who are comfortably using virtual environments up to 7,500 devices without any real problems. Well, hopefully we've helped you see where you're at with automating your management environment and giving you some ideas on how to reach the next level in your organization, no matter what size organization you are. If you have any questions or you'd like to get some additional information about anything you've seen here, please feel free to reach out to us at info@netreo.com or by selecting the appropriate option in the poll. Either way, we hope to talk to you soon and see you at a future webinar. Thanks, everyone, and have a great rest of your day.